Let's tackle question 6, part A. In this question, we are given the triangle PQR with vertices P at the point 0,1, Q at the point 3,3, and R at the point 4,2. In the first part, we want to sketch the triangle PQR on the Cartesian plane. In the second part, we want to determine the equations of the lines passing through PQ, QR, and PR. And finally, in the third part, we want to use integration to determine the area of triangle PQR. Here's a sketch of triangle PQR on the Cartesian plane. P lies on the y-axis at the point 0,1, Q lies at the point 3,3, and R lies at the point 4,2. We simply connect all the points by straight lines to get a sketch of the triangle. In the second part, we want to determine the equations of the three lines making up the triangle, which are PQ, QR, and PR. We'd start with PQ. P is at the point 0,1 and Q is at the point 3,3. Therefore, the gradient is given by the y-coordinate of Q minus the y-coordinate of P divided by the x-coordinate of Q minus the x-coordinate of P, which is equal to 2/3. The y-intercept is equal to 1 because the point P, which already lies on the y-axis, has a y-coordinate of 1. Therefore, the equation of the line passing through PQ is given by y equal to 2/3 x plus 1. Moving on to the line QR, where Q is at the point 3,3 and R is at the point 4,2, we determine its equation as follows. Note that the gradient of the line through any general point x, y, and Q must be equal to the gradient of the line through Q and R. Now, the gradient of the line through x, y, and Q is given by y minus 3 divided by x minus 3, and the gradient of the line through Q and R is given by 3 minus 2 divided by 3 minus 4. Equating both gradients and simplifying, we get that the equation of the line through Q and R is given by y equal to negative x plus 6. And finally, moving on to the line PR, where P is at the point 0,1 and R is at the point 4,2, we determine its equation as follows. The gradient is equal to the y-coordinate of R minus the y-coordinate of P divided by the x-coordinate of R minus the x-coordinate of P, which is equal to a quarter. The y-intercept is equal to 1 because P, which already lies on the y-axis, has a y-coordinate of 1. Therefore, the equation of the line through P and R is given by y equal to a quarter x plus 1. In the third part of the question, we want to use integration to determine the area of triangle PQR. One way to determine the area of triangle PQR is to first determine the area under the curve, under the line PQ and above the x-axis, shaded orange in this diagram, and we label that A. Then determine the area under the line QR and above the x-axis, which we label B, and it's shaded red in the diagram. And then we determine the area under the line PR and above the x-axis, which is shaded blue, and we label that C. Notice that if we sum the areas of the orange trapezium and the red trapezium and then subtract the area of the blue trapezium, we would get the area of the triangle. Therefore, the area of the triangle is equal to A plus B minus C, where A is given by finding the area under the line PR, which is found by taking the integral of the equation 2/3 x plus 1 between the limits 0 and 3. That evaluates to 6 units squared. Then we find the area under the line QR, which is given by taking the integral of the equation minus x plus 6 between the limits 3 and 4, and that evaluates to 2.5 units squared. And finally, we find the area under the line PR, which is found by taking the integral of the equation of quarter x plus 1 between the limits 0 and 4, and that evaluates to 6 units squared. Therefore, the area of the triangle is equal to 2.5 units squared. Hey guys, Dwayne here. If you're a Caribbean student struggling with Cape Pure Maths and you need extra help, then go to this link to join my free study group. Also, don't forget to subscribe to this channel and click the notification icon to get notified when I upload new videos. Thanks for watching, and see you next time.